So hello everybody, welcome back. We're going to continue on with the Canadian Intermediate Mathematics Competition 2011 paper. In this video we're going to be doing question number 4 of part A. So let's take a look at the question. So a die is a cube with its faces numbered 1 through 6. Okay, not everyone's always familiar with what a die is, so it bears repeating. Faces are numbered 1 through 6. It's an important piece of information. One red die and one blue die are rolled. So we have 2 dice, we're going to be rolling them. The sum of the numbers on the top face of each die is determined. What is the probability that this sum is a perfect square? Okay. So when we see red die and blue die, we need to know that these dice are distinguishable at a glance. That's the idea, is that if we roll these dice and the top faces, say 2 and 5, we'll be able to clearly see, oh, the red dice has a 2 and the blue die is showing a 5. And that this is different. This is a different outcome than the red die showing the 5 and the blue dice having its top face show a 2. These are distinguishable events. And in probability, it's all about counting your desired outcomes, your desired events, and your total events. So, with any probability calculation, we need to determine 2 things. We need to figure out the number of desired outcomes, and we need to divide that by the total number of possible outcomes. Okay, so what do I mean? A possible outcome is the red die showing a 2 and a blue die showing a 3. Okay, that's a possible outcome. But they're not the ones we're looking for. We're looking for a particular kind of outcome where the sum of the dies, the top faces, is a perfect square. So that would be like the blue die showing a 1 and the red die showing a 3. 1 plus 3 is 4. That's a desired outcome. We're going to count those outcomes by themselves, and then we're going to count the total number of possible outcomes. And when we perform the division of the 2, that gives us the probability. So we need to pick one to look for first. So first, let's calculate the number of desired outcomes. That is, the number of ways that the top faces can sum to a perfect square. Okay, so first questions first, what possible perfect squares could we be looking for? Right? What are the possible outcomes for the sum of the top faces of the dice? Could we have a sum of 49? That's a perfect square. Should we be looking for ways to get a sum of 49? So what's the smallest possible outcome for the sum? Well, the dice are numbered 1 through 6. The faces of the dice are numbered 1 through 6. So it could very well happen that the red dice gives us a 1, and the blue dice also gives us a 1. They're 2 smallest values. Okay? So if both dice are showing their smallest value, that is 1s, we get a sum of 2. How about the largest possible value? Okay, we can still ask, okay, red and blue. Well, what are the individual largest possible values? The red dice could be showing its maximum value, which is a 6. And the blue dice could be showing its maximum value, also a 6. And that would give us a grand total of 12. So we're looking at possible perfect squares between 2 and 12. What possible perfect squares are there between 2 and 12? Well, there's only 2 of them. Right. 1 is too small. We can't ever get an outcome of 1. Because at worst, we're getting, or at lowest, we're getting an outcome of 2. Likewise, we can't get a 16 or a 25. They're way too high. The highest our dice will show is a 12. So the only 2 perfect squares in between these two are the values of 4 and 9. So what possible ways can we get an outcome of 4? What would the red die need to show, and what would the blue die need to show? It doesn't take long to figure out that, for example, the red die showing a 6, you're never going to get a 4 that way. A little bit of experimentation, we realize, well, the red die values have to be less than or equal to 4, obviously. And if it's exactly equal to 4, if the red die is showing exactly a 4, the blue die would have to show a 0. That's not going to work either. So the red die needs to show a 1, 2, or a 3. And if the red die is showing a 1, and we've got a sum of 4, the blue die's got to be showing a 3. And we can fill in the rest of this chart. So there's 3 possible outcomes when we roll our dice that give us a sum of 4, and that's one of our perfect squares. So we have the red die show a 1 and the blue die show a 3. We can have the red show a 2, a blue 2, red show a 3, and the blue show a 1. These are the only ways that we can get a sum of 4. So that's one of our perfect squares. What about our other perfect square? 9. Okay. So once again, we can do a little bit of experimentation in our head. If you have dice handy, and you're allowed to bring those sorts of things, you could probably do a little bit of trial and error and work out that the red die can't be 2 or 1, because then the blue die would need to be 7 or 8. And those just don't work out. There's no 7 or 8 on the die. But the red die could be 3, 4, or 5, or 6. If it's 3, and we have a sum of 6, the blue die will have to be showing a 6. Sorry, if we have a sum of 9, the blue die will have to be showing a 6. If the red's showing a 4, and we have a sum of 9, the blue has to be showing a 5. If the red's showing a 6, blue will have to be showing a 3. So 4 of our outcomes show us a sum of 9. And since we can only show a 4 or a 9 on this dice, the number of outcomes that are desired, the number that show us a sum of a perfect square, is 3 for the cases that come where the sum is 4, and 4 for the cases where the sum is 9 is equal to 7. So we figured out one of the values we need to figure out the probability. How about the number of possible outcomes? That's the other number we need. Well, the number of possible outcomes is just what possible combinations can the dice show. So at this point, the value of the blue dice, it doesn't matter what the red dice is showing. We're not trying to get a particular sum or anything like that. So there are 6 different face values for the red dice. And there's also 6 choices for the blue dice top face. And we're just asking for possible outcomes. So these guys don't interact. They don't affect each other. The value of the blue dice has nothing to do with the red dice. And since they're independent of each other, we can multiply the choices. So 6 choices for the red face times 6 choices for the blue face. 36 possible combinations of what the red and blue's top faces can be. So our probability was desired outcomes over possible outcomes. Desired outcomes is 7. Possible outcomes is 36. We can't simplify this fraction anymore. So 7/36 of the time the sum will be a perfect square. Right, that's all we're asked to do. Just figure out the probability that the top 2 faces will add up and give us a perfect square. Okay. Straightforward question, simple probability one. It took us a little while to figure out the desired outcomes, but other than that, it's smooth sailing. So hopefully question number 5 will be just as smooth, and hopefully you'll join me in the next video for question number 5.